All right. I think we will go ahead and get started. All right, so thank you everyone for joining the fifth work group meeting for the development of the U.S. early plugging of marginal oil and gas wells. Before we get started, some housekeeping items. So all of the observers are in listen-only mode, and work group members should be actively participating throughout the work group meeting. You can raise your hand to add anything, or you feel free to use the group chat as necessary. Observers are also able to use the Q&A chat at the bottom of the screen. And any questions that we don't get to today during the meeting, we'll either follow up via email or for the work group conversations, talk about them in a subsequent work group meeting as needed. And after the meeting, all slides and the recording will be posted online on the protocol development webpage. And I'm not sure if I mentioned this last work group meeting, but the development page has been moved under the waste and methane section rather than under the industrial. So if you've looked for it, you can find it there. And then again, my name is Rachel. I'm leading the development process and I'm supported by John, the director for protocol development. And I'll move right into the timeline. So today is the fifth work group meeting, and we are still aiming for a public comment period in April and May, but we may need to schedule another work group meeting as necessary following this meeting sometime in April, and with the goal of presenting it to the board for our June board meeting. So for today's agenda, we'll be revisiting some of the conversation that we had last week about the start date and the resulting secondary effects. And then we'll move into conversation around the assessment boundary as well as the leakage adjustment. So some of these conversations will be talking about other sections, mixing in some of the quantification section as well as monitoring. And then we'll complete the meeting with next steps. So beginning with the start date and the secondary effects. So we're considering another way to look at the start date based on our conversations from last time. So another way that we can address the start date is related to when production ends. So this can be done in one way through the contract effective date for the engineer report. So this can serve as a signal as the intent for a carbon project. Um, and then with that, we would also include a requirement for the report to be completed within 12 months of plugging. Or production can also end on the date that the well is plugged. So this would account for projects to continue the production under their current business as usual. Also considering that there may be some secondary effects related to that in terms of changing production behavior. And then there's also a third scenario that we'll be talking about where the production can end somewhere in between those two dates. And so we'll talk about these quick a little bit individually, as well as how this might impact the quantification and any of the resulting secondary effects. So under that scenario one, production could end on the date that the project contracts with the engineering firm to create the report. So again, this can serve as that initial expenditure related to the plugging activities and signal the intent for the carbon project. So if it were to be done on this date, then the marginal well will go idle and then would result in a change in behavior as a result of the project and then have a different emissions profile. So in here, we would consider idle emissions within the boundary, and we could compensate for that during the initial reporting period. So when looking into
Sorry, just to
account,
clarify, are you
sure.
saying that the production would have to cease on the date that the report is issued? Is that what you're saying?
It doesn't have to. So we're presenting different scenarios. So if it were to end on the day that they were contracting the report and they decide, I want the report to fully encompass all of the economic reserves. I don't want to continue extracting. I'd rather have the carbon credits from keeping them sequestered. Then we would want to consider how that secondary effect would impact the emissions. Um,
Okay.
and then to what degree we want to consider that.
To what degree is it stipulated that they must or have the option
Yep.
of
Yep.
stopping on that date? Okay.
Yep. Exactly. So, when looking at this, the California Energy Commission had found that idle wells within the state emit 5.6 grams of methane per hour. So if the average emission intensity for a well, let's say is a well that's producing 15 barrels of oil equivalent per day, then the resulting idle emissions would be about 7.7 tons of CO2 equivalent per day. So there's about a 0.062% difference between those two values. So as a result of the project activity, they're changing their production behavior, which results in this secondary effect of the idle emissions. However, it is a low percentage relative to continued or relative to the baseline behavior. So can we consider this de minimis? And since it's on the alternative side is if we do agree that it's de minimis, should we still consider it within the quantification because it is a secondary effect. And I'll pause there for any initial reactions here. Yes, Jay.
So I just wanted to, I think this is implicit in the conversation, but I just wanted to confirm that it was explicit, which is the reason this start date is so critical is that the expert report, the PPEF report, is going to have the reserve value in that report. And then the reductions are going to be calculated based on that reserve value. So this kind of discussion on the start date and what you're presenting here is really how that reserve number gets adjusted from what's in the report to what they actually get credited for. Am I following that correctly? Because like I said, I think it was implicit in the last conversation, and I just wanted to make sure that we were all on the same page as to why this is a critical decision relative to the offsets that are ultimately produced. Did I get that right?
Yeah, that's definitely one factor of whether production continues and at what rate. And the report would then need to be modified or that impacts the amount of reserves that are left that would be eligible for crediting under the protocol. But then we also have to consider um, based on the project activity, what are the different changes in behavior that will be made by the project developer as a direct result from the project. So part of the conversation is, how far out does this boundary go, and what things are we all considering within the project boundary? If that makes sense.
So it's not only the avoided emissions, but you're also saying it's also the project emissions. And we haven't, again, some of this is to be presented. Is that correct? Some of these are, we haven't seen any of those. We've seen the boundary, or we have a draft boundary, but at this point we haven't seen kind of those equations that these might impact. Is that correct?
Yeah, that's right. Yeah, so
Okay.
part of this will impact what the quantification looks like, but we will be touching a little bit on what the overall picture looks like too.
Okay. Thank you.
Mhm. Reed?
Yeah, just two thoughts here. One, the methodology is built on equating emissions to the amount of oil and gas that it goes abated. So when we start to build in other ways to think about emissions like leak rates and average leak rates per state, we start to play with two different ways in which we want to quantify emissions. So given it's so de minimis, I would lean on not including hard to verify idle emissions in the brief period in between a well going idle and the P&A date. The second and maybe bigger issue here, I think it's going to be very hard to verify the date and hour that production ceased. I think there's no independent verification of that. The only way that we can verify that production has ceased is by checking the date that the plug and abandonment certificate says that the well was plugged. That's at least independently verifiable. So I would tend to lean that the project should start. If we're not choosing an earlier date, the project should start on the date that the well is plugged because that is ultimately the date that it ceased production that we can verify at least.
Any other thoughts here? Any disagreements with that point? Agree?
I have a kind of something I wanted to say. I've been looking up that California study, and I think the the amount that the idols well emit is about 35 grams per hour or 36 on the order of that. So it's maybe quite a bit higher than you state here. Um, I understand the issues of the secondary effects, and I understand the issues that Reed is talking about. Um, anything that would err on the side of being more conservative, I would be for. Um, I would have to think through this a little bit more and what are the different cases. Um, perhaps perhaps we wait until actual P&A activity starts, because that's a clear indication. Um, and there's a less allowance for ways to game uh, how much. So you just take that time, subtract that out of the reserves. I think the way the original, I think, methodology was written as. Am I saying that right?
Yeah, I think that makes sense. Meg?
Oh, hi. Yeah. I also found something similar to Puneet when I was looking for that DEC number on idle well emissions. I mean that the end of life well emission measurement studies are pretty thin. So whenever you get, I think also if that's an average or something that you guys are using, you want to be careful there too, because there's really wide variation in the amount of emissions depending on a lot of things, the reservoir pressure, the condition of the well, how well it's been maintained. I mean, but I don't want to argue with your argument here. If it's de minimis, then yeah, it does. But if there's some way to either be conservative, like Puneet's suggesting, and you wait till it's plugged, or have some kind of verification on how much it actually is emitting, if it's some sort of monitoring of that well between when they turn off production and when it's plugged. And I guess also if there's some kind of required time frame from it going idle to when it gets plugged in your methodology, that might take care of this as well. That's all. I see Reed's got his hand up.
Yeah, Reed?
One other thing to take into account, just generally, I'm trying to lean on things we can independently verify outside of the operator's word. It's gonna be hard to know if they actually took the well idle. Let's imagine that they produce a barrel and a half over a 6 month period of time. Was that well really idle? Or was there just remaining production that was able to be captured? Our goal is to get this well shut down as soon as possible. So if the operator finds out that they are penalized for some average methane leak rate by taking it offline earlier, there's an argument that they'll want to keep that thing producing all the way up until the plug date. So I think, the goal here is to keep as much hydrocarbon in the ground as possible. Let's, build in incentives to do that. And so if we can run a reserve report on Jan 1 that says there's 10,000 barrels left to be sequestered, they take the well off, Jan 10, it produced 2 barrels, and they're getting the credit for most of that reserve report. That's great. And we really want to incentivize that to happen as soon as possible. I just worry about building in complexity to an already complex model.
Meg?
Yeah, I hear you, Reed. So is there a required time frame then from the time they plug it in and then the time they're going to plug it? So, if things go south, there's less opportunity of it becoming a perpetual idle well, which, we have a big problem of that too.
I think the draft methodology says that the reserve report that states how much of a credit they would get has to be done within 12 months of the P&A. But they only get credit for the emissions attributed to the oil and gas they do not produce that would sit on that reserve report.
Mhm. Okay. So some of these next scenarios sounds like based on our conversation, I mean, we'll still touch on them quickly, but from our conversation, sounds like for, I guess, partially simplicity to use the plugging date. Um, so maybe we don't need to spend as much time on these next slides, but presenting some other scenarios where, let's say, we're going with the plugging date, but what happens if they decide to increase production relative to their historic production levels, um, as a way to, you know, extract more, increase production to sell that rather than keeping it in the ground and receiving the carbon credits. So in this case, there would be an increase in emissions relative to their baseline as the secondary effect. So as Reed had mentioned, and Jay as well, the production from those reserves would then be extracted from the evaluation report reserve determination. However, as a result of the plugging, they may be changing their behavior to increase production for the sake of getting more hydrocarbons before they actually plug it. So in this case, would we want to consider the increased emissions from that increased production above their historic production levels? And if yes, having a larger look back period than maybe we've discussed before when defining like actively producing, to look back over the course of 3 years to get the average daily production, to determine, what that increased production rate would look like. Meg.
Um, I don't know how much of a problem this is. Once your well is marginally economic, it's in its last stages anyway. There's not a lot of reservoir pressure. It's usually not economic enough to apply, enhanced oil recovery or gas recovery. So I just don't know how much of an issue this is. And folks that have more industry experience here can correct me if I'm wrong, but usually not worth that if, they're limping along these wells. I don't think you can turn them up very easily.
Mm-hmm.
So I don't know. Is this a non-issue? Can Reed or somebody else or somebody with more direct operator experience comment?
I think the hypothetical we wanted to prepare for was that if the operator is not getting any credit for what happens all the way up until the plugging date, then they're going to produce as much oil and gas as they can during that period of time. But if, as has been proposed here, you get a reserve report that says you have 10,000 barrels and you take that well offline the next day and you get credit all the way up until that plugging date, which could be a month later or 2 months later, they're going to be incentivized to take the well off production as quickly as possible. It's just about like, if the reserve report has to be done on the plugging date and you only get anything from that point on, that may change things. But generally speaking, the operator is going to work to maximize revenue. And if they know they can maximize revenue by not producing oil and gas, that seems like the route they'll go. If the revenue is greater by producing oil and gas, they probably wouldn't take on the project in the first place.
Wes?
Yeah, just going off of what Reed said and what you were talking about, Margaret, the production on a marginally producing well is going to be de minimis. There's not a great risk of having them going out and like doing more work to make it more productive, because you're going to have to spend the money to get it up to where it's productive, where it would be worth it. I think you have a valid point. Like, you don't want people could go out and do that, but I think if you incentivize it, like Reed's talking about, you're going to see that even go down further, where you're going to be making it economical to not do workover and not increase production. Because once you're down to the marginal standpoint, you're going to have to do work on the well. You're going to have to increase pressures, put more money into it to make it produce maybe an extra barrel a day. And you're not going to recoup that money as easily on the workover side as you are just leaving it and not doing that work and getting incentivized to leave it in the ground, as Reed's talking about. But the only variable I see would be if you had multiple well projects, which would be another variable you'd have to look at. Is if you're going to have multiple wells in there, is someone going to increase pressure in like a water flood area or have some issue there? I haven't thought about that as much. I'll think about it some more and submit written comments on that if I think it's, if it's worthwhile. But that's the only other little wrinkle I could possibly see.
Yeah, and to your point, Wes, that reservoir communication piece will be shared with everybody in like the next set of documents that we plan on sharing. So you should be able to see that within the next like few weeks, or at least like week or two.
Okay.
And then you can provide written comment with what we have on that.
Okay.
Panee?
Can we, two comments. Can we limit the amount of time between the PPF report and the time the plugging activity begins? And then second, is there a Reed, you had mentioned it's hard to prove whether an operator has begun idle. Is there a way to prove that they've shut in, or is there anything that they can prove that they've stopped production in some way that doesn't inhibit the following project?
The things we can independently corroborate are if they change the status of the well with the state. If they move it from being active to inactive, which is a well status process. I don't expect that to happen. I think there's going to be such a short time period between when they decide to do a project and when they kick off shutting down the wells that you'd move pretty directly from active to plugged. We also probably can't corroborate when they start the plugging operations. We can for sure corroborate the date that comes from the state on the certification letter that says when the well was plugged. That's about as ironclad as we can get. So, and we can typically corroborate the amount of production that the wells produced up until that point.
Okay. Can you get photographic evidence of the plugging rate?
Absolutely. Almost every time you'll have a team from the operator as well as somebody from the natural resources department on site doing a bunch of examinations, photos, things like that.
Wes, go ahead.
Oh, I was just gonna add to that. I don't know if we put in, or if you can put in just kind of like best practices or things like that, but typically, like I know when we have workovers and we have rigs that are moving on location, that'll be documented. And it might even be from a payroll standpoint. I don't know if you put that in like an FAQ, kind of like ARB's done, like this is like a best practice maybe, that when you go do these projects, you collect that data from the contractor or if you're doing it in-house. But I know, and on our well cementing stuff, we have, when we show up, when we start pumping the cement, when we conclude pumping the cement, and then what time we're off location. All those records are typically readily available. But the workover rigs, even sometimes they'll have like day they show up, day they rig up, and things of that nature. But I don't know if you want to put that in a protocol per se, or if you want to have that in like a comment maybe. But that's just my 2 cents.
Wes, the draft protocol has a data requirements for verification, and it goes
Okay.
through everything that you need from the state, from the plugging crew. It's a long
Okay.
list, so be excited to get your feedback on additional data that would be needed to corroborate how the plugging operation went.
Yeah, and we even get it down to, I don't know if you guys are considering like the types of cement, but we can get into that later. So,
Mhm. Nate? Yeah.
Then after hearing this, I would be okay with having a relatively high methane emission penalty. Like relatively high meaning like 35. I mean, I think for an idle well that's reasonable. I think the other one, but just as a penalty, just as an incentive, like you'd be penalized this much just as an incentive to because methane itself is from an MtCO2e standpoint is going to be a heavy penalty. Um, and so I think that could incentivize plugging earlier. Reed?
Yeah, Reed, go ahead. I think Rachel
Okay.
might be.
Then we just get into who does that measurement, how do we corroborate it, how often we're doing that measurement. We're going to run what sorts of like sensor technology we're going to have out there, because
No, it
nobody's
wouldn't
reporting their
it wouldn't be a measurement. It would just be a penalty that for every day between the PPEF report and when wells get plugged, which you'd verify using, photographic evidence, like that would be a subtraction penalty, and then you would just use that 35 grams a day penalty.
to incentivize them to go from the reserve report to the plugging date quicker.
Yes. Would that make sense?
You mean the report, or if they're ceasing production, if they're ceasing production prior to plugging?
Well, I would say that once they get the report, you would tell them to cease production or within how many days if they're going forward with the project and then penalize them. I don't know. I'm just trying to think of incentives that would incentivize a faster time to P&A activities.
We can definitely think about ways to incentivize them to get to a full P&A quicker, because that seems like a good thing.
Yeah.
We are incentivizing them to take the wells off production as quickly as possible because that's how they maximize the credit volume attributed to the
Right.
project. But what we
Right.
don't want is them to take the well off production, have massive methane leaks for 12 months straight, and then plug the well.
Yeah.
So that's definitely something. Let me get creative and think of some ideas on those incentives.
Yeah. Maybe a per day methane penalty plus a limit on the number of weeks or months between between idling to P&A activities or something. Anyway,
Yeah, we want them to take the well off production as quickly as possible. If they can't get a crew out there to plug the wells within 4 months, I don't want to penalize them and make them run the well actively all the way up into P&A date.
mhm. Yeah.
So yeah, I guess that's something to continue to talk about. Again, I think the methane leakage rate, even at that 35 grams an hour, is going to be de minimis versus the total carbon credit potential of the project.
Right.
But yeah, incentivizing them to go from off production to P&A and get the whole thing underway as quickly as possible is a good thing, and so we can play around with ideas there.
Okay.
Okay, great. Sorry about that. I lost my internet connection. Okay, so we can think about that a little bit more, and please provide written comments as you're able to think about this a little bit more. Okay, one of the other scenarios would be if they were to, continue producing at baseline levels, which wouldn't result in any secondary effects, and rather kind of with what we've talked about a little bit already, then just the total production volumes would be deducted from the evaluation report if the evaluation report is done before the well is plugged. Then there's this third scenario where they produce less than they would have relative to the baseline. And in that case, you would still have to deduct the volumes from the report. But then it would also result in a decreased amount of emissions prior to plugging. And we would not consider this within the protocol and how it's credited, other than the fact that they would have, more reserves to be credited. So there wouldn't be any type of penalty or further consideration for this. Then we kind of have this third approach that it's somewhere in between, but that will fall along the lines of some of the other conversations that we had about maybe like some type of combination approach, depending on how we decide to proceed with those idle emissions or any type of increased production. Before we move on to the assessment boundary, is there any other comments related to what we've been talking about for the start date? Okay. So we provided everyone with the draft proposal on the assessment boundary. We will be going through each of those components individually, as well as presenting some alternatives from the draft that we had shared. But I'll begin with some foundation, and then we can build into the proposal from there. So the purpose of the assessment boundary is to identify relevant sources, sinks and reservoirs, or SSRs, that are applicable to the baseline and project scenarios. So all SSRs relevant to the project and the baseline will be identified, but it doesn't necessarily mean that every GHG emission from every single source will be quantified. So after we're identifying the relevant sources, then we'll need to determine what's excluded versus what's included in terms of quantification. So things can be include or will be included when the project activity has significant impact on those emissions. And things can be excluded if it's conservative, like it's assumed to be equal in the project and baseline scenarios, or the project would result in a decrease in emissions of that source that's relatively minor, or it's not sufficient information to be able to quantify the impact. And we can also deem something as de minimis, where emissions are less than 5% of the total emissions, and those can be excluded as well. So we'll talk about the proposal. So here's just an overall picture, including some minor changes related to the draft that we had shown you. So we'll take some time to go through some of these individually, but here's just a broader picture of what the assessment boundary would look like. So the gray boxes are what's applicable to the baseline, and then the black is what's applicable to the project. And then anything inside of the dashed box would be considered inside the assessment boundary and would be quantified. And then anything on the outside would be considered excluded. So we'll just begin quickly with the proposed excluded SSR, beginning with the emissions associated with the drilling and exploration of the well. So this is proposed to be excluded since the emissions occur in the baseline and would occur regardless of whether the project is being implemented, and it's not impacted by the plugging of the well. I will just take a second to pause here in case anybody has any concerns with that. We'll go into each the other SSRs in the coming slides.
Fine with that. It's a sunk cost, basically. As long as, and this is something we'll have to discuss later, as long as there's no drilling and exploration post plugging P&A activities on the same reservoir.
Hmm. Yeah, something like that would just be considered under other sections of the protocol and would
Yeah,
impact eligibility and
yeah.
different assumptions. Okay. Um, then included SSRs, so anything inside of this box. So again, I'll begin with the overall approach with this. We'll get into some of the specifics within the assessment boundary. We have 8 proposed included SSRs within the boundary, 6 of which are attributed to the baseline, are the main source of emissions. So the manufacturing and extraction, the intentional flaring and venting of gas, processing and refining of the hydrocarbons, the transportation emissions, end use combustion of the fuel, and the intentional fugitive emissions attributed to each of the processes. And then related to the project, there's the idle wells, which is just a reflection of the point that we had brought forward. So that will be the details of that will be thought through, and we'll provide some next steps on that consideration. And then we'll talk as well specifically about the plugging and abandonment emissions on a second slide, but focusing on, some of these baseline emissions. Um, any immediate reactions here? And I understand some of the more comments might come related to the quantification approach of this, but is there any reason why some of these baseline emissions should not be included? Um, any immediate reactions here?
I think the main question is for the well P&A, which you bring up, is whether it would have happened, whether or not, the project went through or not. And, there could be uh, arguments for each. Um,
Hmm.
so, I don't have any opinion on one way or another. Obviously, I'd like to lean on the more conservative side. Um, uh, a good maybe one way to take is a probability assumption. What's the probability that this well would have been plugged um, within the crediting period? And and there could be a we could have some estimate based on the plugging rates during that time, going back and make some assumption there. But um, yeah. That's I think what you bring up and the kind of the main issue with the boundary.
Mhm. Yeah, when we were thinking about whether to include the plugging and abandonment emissions, there's kind of two ways to look at it. One way is, making the assumption that it would be plugged in the baseline. However, there is other fates, and we all know that it is common for some of these wells to go orphaned and abandoned. So, it might be it's likely the conservative approach to include the plugging and abandonment emissions within the boundary, even if it might be, um, not a large quantity, but it might be more conservative to do so. Um, and within that, what would we include with the plugging and abandonment emissions? From my understanding, one of the largest source would be related to the fossil fuel emissions used to plug the well, which we can do so through like invoices to get the quantity of the fuel, multiply it by emission factors. But then there's also the embodiment emissions of the plugging materials, which could also be done under a similar approach. So it's a matter of, yeah, how far do we want to go here, and how conservative should we be? Read.
So if we think about conservative as the thing that generates the least amount of carbon credits from a project, that would be assuming that 100% of wells get plugged the day that they stop making a profit. If we start to assume that some wells don't get plugged, then we have to credit the operator with stopping emissions attributed to an idle period, and then credit them with stopping emissions attributed to potentially an orphan period. And that's really hard to project. These methane leaks can go up and down with the weather. So if we assume that every single well would be plugged on the day it reaches its economic limit, we really limit the amount of credits that we're issuing for any project. It's also verifiable under the reserve report and simplifies the project greatly. It does create a bit of a conflict because we're assuming all the wells get plugged. And so when we start to cut from the emission reduction, well plugging emissions, we're sort of duplicatively including those in the baseline and non the baseline. However, when we've looked at the emissions of plugging a well, it's almost always going to fall below 2% of the total emission reduction here. So if our goal is just to be conservative and not really care that it's included in the baseline and in project, I think it's fine to assume all wells get plugged and also include project emissions.
Hmm. Okay.
So just to summarize, it is basically on the level of de minimis, so you're not so you'd be okay with including it more on a sense of trust basis on the methodology.
I'm always going to seek conservatism and simplicity.
Uh-huh.
So, like conservatively, the most conservative thing is to assume all wells get plugged and also take from the emission reduction credits how much it created in emissions to plug the well.
Hmm.
Simpler would be to assume all wells get plugged and recognize that the well was going to get plugged in the baseline. So you don't
Hmm.
take from that emission reduction the well plugging emissions.
Hmm.
But whichever way we go on this, it is not going to meaningfully affect the total credit issuance. So
Okay.
I'm at whatever Climate Action Reserve believes is the best route to go here.
Do you have some calculations that show the rough kind of project emissions if we were to include them?
Yeah, actually, American Carbon Registry did a good job on this in their orphan well protocol. And there's quite a few orphan well protocols that like define those well plugging emissions. So there's a couple
Hmm.
different ways to look at it, but I think Rachel said it well. It's the cement and embodied emissions, and it's
Hmm.
the fossil fuel and diesel usage. But again,
Right.
it's going to be a fairly small amount unless the project is incredibly small.
Okay.
Okay. Great. Yeah. All that makes sense. Okay, so we can include a recommendation in the next set of drafts that you guys see. Um, So another part of considering, what other emissions should we include on the project side would be, taking the time to acknowledge that maybe the cement plugging might not be 100% effective, and it could result in some of the methane being vented from any like cracks in the cement or something like that, and result in these fugitive emissions post plugging. So we wanted to get a better sense of whether it should be included, how significant are these emissions, and then if it should be included, it would likely require direct monitoring. So we included some approaches here that were listed in the Department of Energy's post-plugging monitoring guidance. So that would be something that would be an ongoing monitoring requirement for these projects if we were to include that, assuming that we wouldn't take a default approach due to the acknowledgement that wells would have varying degrees of fugitive emissions. Arjun.
Is it the intent that the annual verification exercise would include site visits?
Yes, most likely. It's something that we would need to discuss more internally. We're open to your thoughts, but it's common practice, at least for our methane and industrial, to be at least every other verification, unless there's been significant changes to the project. So that's a conversation that's yet to be had.
Okay.
Reed.
I'm fairly certain that if a well is plugged and it is showing fugitive methane emissions, the state will not certify that the plug was done correctly. So I wouldn't include this as a feature, but instead a bug to projects, in that if on the first or second or third verification event, there is a methane leakage sample taken and it is leaking methane, that should cause project invalidation to some degree.
Okay. Panit?
Yeah, I agree with Reed. Even if there was a a it wasn't 100% effective, the amount that you emit would be very tiny, as long as you're using the most, common and approved and standard plugging, modern plugging techniques. I guess then the question is, how often do regular verification, how often does that happen? And when do we want to trigger an extra verification for fear that something might have happened, like, for instance, some seismic event?
Mm-hmm.
Um, so that would be the thing, because I'm guessing, like, just that these would be high cost, kind of, because these would require um, someone to go and actually measure it. And while they have the high enough accuracy to actually measure the leak that would be coming out of a plugged well, it's also going to be costly, and that leak is going to be tiny.
Mm-hmm. I know that especially in the past few years, and I'm sure more so coming up, there's a lot of like satellite imagery related to being able to identify methane. So is that a route that could be taken as well?
No, the satellite imagery is not going to be able to detect grams of methane per hour, and after plugged, it'd be even less than that.
Okay. Meg?
Oh yeah, I was just going to mention, there's an NAS study coming out soon on well plugging, which is exploring techniques and effectiveness and the latest technology in that, just for your awareness. My boss, Adam Peltz, is on that committee, so I can find out when exactly it's coming out. And also just, in terms of the monitoring space, there's a fair amount of or there had been, maybe not as much now, development going on in that area. And I'm aware of one group that was developing a low cost monitor just kind of for this reason, I think with this kind of in mind, to install near plugged wells to with a a low sensitivity. So if there was methane leaking, there some kind of alarm would go off or something.
Mm.
Anyway, that's all.
Thank you. Wes?
We've got a flow rate system that we've used and got it developed for sampling wells and everything. And kind of back to what you were saying about the satellite imagery and everything else, I just want to bring up this one point, and that you're going to have leakage from potentially more than just the well. You know, tank battery sites on location and everything else. So when you think about satellite imagery, you could have more than one source. It's all coming from one source, but it could be coming out of the tank battery as well as from the well. So just something to keep in mind.
Yeah.
And I don't know if you're wanting to include those emissions in here or not. That was part of the Quad O stuff that the government was going at for. So
Mm. Okay. Yes, Paneet.
Yeah, so just a background on some satellite imagery. This is something that I've been kind of studying and looking into. The best you're going to get from a one-time snapshot, let's say methane sat was roughly the best that you could get. It's not available anymore, but that's maybe a 50 meter by 50 meter snapshot of concentrations, not necessarily flux measurements. And you're gonna, to get an actual flux measurement, the limit of detection is gonna be on the order of 20 kilograms roughly an hour. So I just don't see satellite as being an option. Um, the monitors are interesting. I've been studying those as well. Most of them cite a limit of detection roughly on the order of a kilogram per hour, but that's based on putting them as like a fence monitoring around a site and then using inverse modeling to kind of deduct a flux measurement. I don't know of any studies of those type of monitoring instruments being put directly over a plugged well. That would probably give you the best chance. But again, these aren't uh, certified, at least made for that use. And I haven't seen any certification for that these would be the appropriate type of instrument or a case study yet. So I don't know, Margaret, if you've seen something like that, I'd love to know. But for right now, I don't have full trust in these kinds of measurements yet, for especially at the rates of emission that would happen in a plugged well that had a failure.
Yeah, this is something that Drew Pomerantz at Schlumberger is developing, and
Yeah.
it's pilot stage. It's not commercial yet, but I'm sure he'd be happy to talk to you about it or anyone
I've
else that's
I've had
interested in
many a
that
deep
tech.
conversation with Drew Pomerantz.
Yeah.
So this is my assessment after those conversations.
Yeah. No, and you're correct. Methane sat. I've been told over and over by those scientists that they can't, the resolution they can't detect emission rates. They can't, narrow it down to orphan wells or any of these individual wells.
Yeah.
But they're going to work on another one, so maybe that will advance.
Yeah. So my then recommendation would then be having regular verification, if that is indeed what is already included as what we're planning to do, using these low limits of detection methods and or a triggering event which would necessitate an ad hoc verification method such as like a seismic event.
Okay. Yeah, we can consider that more internally. Sorry, I don't know if you're seeing. Okay, sorry. Um, Great, thank you all. Yeah, so sounds like we will think about adding in other mechanisms to be able to confirm that the integrity of the plug is held up over time with extra mechanisms, like you had said, to confirm that or that like after an event, some type of severe weather, that they would be required to confirm that the well is still plugged and there's no infrastructure damage, and that the monitoring would likely be difficult because of the low detection levels. Okay. Next, we wanted to start a conversation related to the leakage adjustment. So really focusing on um, the market leakage at this point. So I had mentioned before that I was going to share a high level overview of like how all the equations are going to interact. And for this purpose, wanting to give a high level overview to show where the leakage adjustment would then come into play. So that would be here within the baseline emissions, having a leakage adjustment based on that market leakage. And then I did include, some other considerations like this increased that was related to if we were to include that based on our earlier discussions. But really focusing our conversation today on market leakage. So this protocol is incentivizing a reduction in supply for marginal wells. So when supply is reduced, prices go up. However, for oil and gas, it doesn't necessarily translate to a decrease in demand as a result of the higher prices. So when supply is reduced from one source, a portion will be produced by another source to supplement the market and meet demand, which is the market leakage. And leakage is a function of price elasticity of supply and price elasticity of demand. So when we're reducing the supply and prices go up, we have to evaluate how this increase in price will impact consumer behavior. And so when looking at this supply side intervention, we have to consider the demand response as well as the emission intensity of where the hydrocarbons will then be produced when it's being produced by another source. So understanding that it could be produced by either cleaner or dirtier fuel source. And we'll cover some of these topics and how it relates to the market leakage adjustment, beginning with an existing study looking at market leakage from supply side intervention, as well as considering the nuances within the argument and whether we need to talk about an oil versus natural gas or looking at a different assessment level, whether it's national, regional, or state. But we'll get into those in individual slides. So first, I wanted to present an existing study by Resources for the Future. They looked at the supply side intervention from oil and gas, from oil markets and the rate of market leakage. So part of it, they compiled the existing literature for demand and supply elasticity from oil and found that the demand elasticity at a national level was an average of negative 0.33, which makes it inelastic, and the supply side as 0.42, which is elastic. And based on these averages, they estimated a national market leakage would be 56%. They also looked at that second component of supply side intervention, the emissions intensity, and found that North American oil is 4% more emissions intensive than other countries. And they ran 1.53 million Monte Carlo simulations for different scenarios and found that 98% of those scenarios resulted in a net decrease of emissions, when shifting supply between the different resources. So this suggests that when the protocol is incentivizing plugging a marginal well, 56% of the supply that's sequestered by the project will then be made up elsewhere in the market. But that source is more likely to result in a decrease in emissions to produce the same quantity compared to the dirtier source. So this study presents a national market leakage rate for oil at 56%. And so I wanted to pause here to see if there's any immediate reactions to this value. Does 56 seem to be too high or too low? Meg?
Well, I mean, marginal wells in the US are producing less than 6% of production, of oil production anyway. And I think it's maybe about the same for natural gas production. Yet of the 900 or a million wells we have, 80% of those are or more are marginal. So 95% of US production is coming from less than 20% of the wells. So, and recent study, like the studies that EDF has been doing, granted, there needs to be a lot more measurement of emissions from marginal wells, but we think that about half of U.S. upstream methane emissions is coming from end of life wells, mostly marginal wells. So that 56%, maybe that's right, but I mean, it is definitely the dirtiest source in terms of emission intensity of our production. So I think putting it in that context helps too. EDF puts out this well distribution report. I mean, EIA, and I used to manage the team that put out this report for about 5 years, puts out the well distribution report, which breaks down, where you can get these buckets and you can figure out the amount of production in every state that's coming from marginal wells. So, yeah, I mean, I think you got to keep it in that context too, that 5%, less than 6% of domestic production is coming from 80% of the wells, which are marginally economic.
Reed?
For context, I assume that Climate Action Reserve has other supply side intervention methodologies that have leakage discounts. Do you know how large the discounts are for Climate Action Reserve's IFM methodology, for instance?
Yeah, it is 20%.
Okay.
Arjun?
Yeah, so just to keep the focus on the purpose of the market leakage adjustment, I assume that it is so that we can adjust for the differential in how much fuel is actually burned at the end, how much product, so adjusting for how much, for those CO2 emissions from the change in the amount of fuel that is burned. That's correct, right? That's the purpose of this piece.
Yeah, so it's to understand that while we're incentivizing a reduction in the supply, the demand isn't necessarily going to then also be reduced because the demand for oil and gas is pretty inelastic. The demand is there pretty much regardless, especially in the short term, due to the lack of alternatives for one part. So we have to try to the best of our ability, take a deduction knowing that somewhere else in the market is just going to make up that production that we're taking away.
Right. So you're not just assuming that because you took this production off, 100% of those, of that fuel just stays away from the market. And you get a 100% reduction in that CO2 emission at the end. Now you have to discount that by 56% in terms of how much fuel is burned. That's the point, right? So.
Arjun, that does assume that the replacement supply is equal in emissions intensity to the sequestered supply.
Okay, so there's a differential in the upstream in the upstream production as well. Sure. Okay. Yeah.
Yeah, with marginal wells, especially in areas like California, where you have high emissions intensity production, both upstream, midstream, and downstream, the way leakage works actually incentivizes a project developer to focus on the highest emission wells
Hmm.
to decommission first, because the leakage percentage actually comes down because the
Hmm.
replacement production would arguably be lower emission.
Okay. I see what you're saying. So, so then that would suggest that we shouldn't fully discount at the upstream end, because you're getting cleaner replacement production than that one that you shut down.
Assume a fixed average replacement production, or at least the current models. Assume that the replacement production for taking supply out of the US market is about a half a ton of CO2 per barrel of oil equivalent. So if you take on shutting down a steam flood unit in Southern California, it's closer to about 8/10 of a ton,
Okay.
then you are able to reduce the total leakage by that differential.
Got it. Okay. Thank you.
Neat.
Yeah, this is something that internally at the Carbon Containment Lab we've been discussing at length. And to be open, I've been discussing with Reed too about his thoughts and getting as much information as I can, even from other people nearby, even from some economics professors here in New Haven. Um, and this is something that we haven't come to a consensus on here in the lab. Uh, you know, I understand the paper where this paper is coming from, but there's a lot more complexity on both sides. One is that this is, when you think about uh, market leakage, and when it comes to fossil fuel production, it's a stock and flow issue. And in this case, you're not reducing the total stock of hydrocarbons, you're reducing the flow of that stock. Um, and so whether that flow is affects prices in the long term, which is what the assumptions in this paper make, or whether that adjustment in price is more of a short-term issue. That's a big question. Also, it has to do with the capacity of distribution. Depending, certain oil fields have a distribute, and that comes to this flow issue, whether if you cut off supply um, and you have uh, capacity for other supply to come online easily from that same area, then your elasticity would probably be um, better than not. And I'm trying to now remember what exactly was said, but I just want to state that here market leakage, if we wanted to err on the side of conservativeness, we'd err on the side of more market leakage. Um, this is a tough one. And when we come to what Margaret said about marginal wells being the leakiest wells, totally agree, totally on board with that. But the way the emissions are calculated on is on a basin average, and so we don't know based on the OCI's emission intensities, which it doesn't break out the leakiest wells from the non-leakiest wells. Fugitive emissions for some basins have values and some don't based on the satellite emissions. That's basically how those fugitive methane emissions are determined. So I just find this problem really hairy. Um, and whether the market leakage of 56% is the right market leakage or should it be much higher, I'm still not sure about that.
Okay. Reed?
It's a reduction in stock.
I'm sorry?
Reduction in stock.
Oh, I only hear like the last few words that you say. It's production in stock that.
A stock and flow issue.
Yeah.
So we're reducing flow, but I'm under the impression we're reducing stock because the amount of oil and gas is permanently sequestered that stock is no longer in market.
Okay. If you can guarantee that that basin or that reservoir is never used again, then that is.
Protocol anticipates that we temporarily keep that oil and gas in the ground and it reaches the market later. I think it's the nature of storing these emissions in the geosphere on a permanent basis, sort of the ambition of the project. Additionally, it's not just about the reservoir. We're talking about the exact barrels on the decline curve.
My earphones ran out here. We're talking about the exact barrels on the decline curve for that well, not just what's left in the reservoir. So all we need to make sure is that those exact barrels are not produced, not everything that would exist within the reservoir. The other thing to just point out here is we're talking about a leakage discount that is 3 times larger than any other project that has ever been in the carbon market. If anything, I would say we are erring on the side of a very high leakage discount here. Now, the Rocky Mountain Institute spent almost a year on this research to try to match or beat any other research that's been done on market leakage as it relates to any commodity for supply side intervention. So, if we choose to step away from the greatest research that is available to us today, I think we need to provide greater research. But if we believe that we go with updating research that continues to get better over time. We're starting at a very high number with 60% of all emission reductions from plugging a well not counting as a carbon credit. It feels pretty strong, but again, very open to changing leakage amounts if we can provide research that trumps that's available today.
I'm totally in agreement with that. As more research comes online, even the paper said that as elasticities change and we get more data on elasticities, especially the most current elasticities, then this leakage adjustment should be revisited. And then we should also definitely, if we can, do leakage adjustments based on oil and gas because gas is going to be very different, especially right now where a lot of gas is being curtailed, and one could assume that you're going to substitute for even worse emissions from coal. And then also on a basin by basin, um, uh, if possible, adjustment.
Yeah, we'll be touching on those topics in the next slide too. Meg?
Yeah, I totally agree with you guys. I mean, I spent a decade at EIA tracking oil markets, working on the short-term energy outlook, trying to forecast U.S. oil and gas production and tracing it really closely, at the well level, pretty much how our modeling worked, and in every basin and play in the U.S. And what dictates whether whether operators are going to drill a well is the oil price, obviously. If we're talking oil markets, and there was a lag of about 2 months following various trends. And, this 5% of US production coming out of marginal wells, I can assure you we were not paying attention to that. And that really made no difference in global oil price. We at the EIA, they track the global stocks and of oil and the flows, and that's what dictates the oil price, and that's what really dictates whether more drilling or production goes on. I mean, nothing to do with these marginal wells made any difference in our modeling. So I think this is overblown as well.
Okay. No, that's really good to know. From that too, and some of you have already touched on this, is considering oil versus natural gas separately. So, how granular do we want to go here? We can look at the difference of responsiveness on demand for natural gas. So, studies show that the demand for oil and natural gas has like a low responsiveness to prices in the short term due to the fewer substitutions when the price is high. But it can be more elastic in the long run when there's more options available. And each, natural gas and oil have they will change. The prices will change depending on different factors. Kind of like what you had said, Meg, that oil is more responsive to the global market. So the supply from OPEC and non-OPEC countries and the financial outlook and as well as on the demand side, the availability of substitutes and fuel alternatives, public transport, things like that. But for natural gas, it can be more regional dependent. So based on weather conditions and with the demand fluctuating based in the seasons, and also the availability of domestic production, imports, and the rate of export. So while both of them, oil and gas, may be inelastic, they have different rates of elasticity, and they're also influenced by different factors. So in that case, should we be having a different value for oil versus natural gas? Sounds like from some of the conversations we just had, yes. And if so, from your understanding of the market, are you aware of any studies related to natural gas that we could use to pull some to determine the market leakage for natural gas? Reed.
Yeah, I think it's simpler to stick with one, but it's probably more accurate to go basin by basin and distribute between the two commodities. Gas is going to be a lower leakage rate because of the amount of production that exists that is non-economic. Every time we talk to operators, they've got about double the amount of wells that produce with no profit. And so the inelastic rate of supply is going to cause that to be lower. The same author who did the first study that talks about it writ large drafted the second study, which goes basin by basin and commodity by commodity. So, Rachel, you should have that study that breaks out between oil and gas and basin by basin. But again, we're going to have to update these. Every time that you typically would update a methodology, I think we're going to have later and greater leakage data to work on.
Mm-hmm. Yeah, we do within our program manual state that we'll update or reevaluate protocols every 3 years. So this will definitely be something that we note for future updates to definitely to revisit. Panit?
Two things. I kind of want to. I think I misspoke. It was just the opposite. So to the extent that so the cost of production in the wells are marginal, so it's roughly equal to the current price. So if the price of oil goes up, these wells wouldn't be pumped anymore. Um, well, no, I guess the other way. If they go down, they wouldn't be pumped anymore. The cost goes up. So if you're thereby reducing the supply of oil, so you reduce the long-term supply of oil, but this does not reduce the flow of oil, just the non-renewable stock. So it's the flow that generates these annual emissions. So again, all I'm saying is that it's very complex, and I'm not exactly sure. Maybe Margaret has a better idea, but Margaret, you said that this is overblown, so I want to know what you meant by that.
Oh, I was referring to definitely to oil markets. I haven't thought so hard about for natural gas. What I meant by that is um, since decisions that are made about drilling, let's say in the Permian or whatever for oil right now, based on the price of oil, that's really what dictates, what an operator is going to can afford to do that. And from what I saw, behavior of the oil and gas industry over the last decade during the tight oil and shale gas boom, just really had nothing to do with what was going on with marginal wells. It had to do with the price of oil, which is dictated, which is very elastic and it's a global commodity, and it depends on what's it's a it's what the world, it's what the global, what's going on in the global market, not what's going on with the 5% of production coming out of the US from marginal wells that dictates that price. It has to do with it. So if you're seeing an uptick in US production, it's it's not due to, reduced production from marginal wells. And that reduction in 5% of production, yeah, maybe it's going to impact a little bit the global supply demand scenario of oil, but is it significant? I don't know. I mean, 56. I don't know. Just seems like it would not be a huge factor here. So that's why I thought it was a little overblown, because I don't think it's going to have a lot to do with oil price. I mean, when OPEC was trying to flood the market, they were trying to shut down the unconventional producers. They weren't trying to they probably put a lot of the marginal oil operators out of business. But that's what I meant. I mean, it's from what I've seen, it's just from just observing and trying to forecast U.S. oil and gas production at EIA. We were not paying too close attention to the marginal wells. That was part of the accounting, but that was not where the action was at all, and it really didn't have to do anything to do with whether conventional operators were scaling up or scaling down.
Mm-hmm.
What OPEC does makes a much bigger difference.
Okay. So I guess based on this conversation, it seems like to Reed's point, it's similar with one and with oh sorry, simpler to have one leakage rate applied across both wells, but also understanding that um the responses within the market are likely different between the oil and natural gas. Um, but when looking down to down to like the well level, marginal wells tend to have less of an impact on a lot of these general behaviors due to the low supply that they're providing to the market. Okay, so then the last consideration that we wanted to bring up related to leakage, and I realize we only have a couple minutes left, so I'll just take a second to present it and see if there's any initial reactions, or well, since we talked about this a lot already, but considering, how detailed we want to get also in terms of the market leakage, if whether we want to go down, whether we want to use like one market leakage adjustment for the national, or whether we break it down into regional and state leakage adjustments. I did find, some two different studies that looked at the natural gas in particular, and found that there is large variability between the demand elasticity for natural gas on a regional and state level. However, not every region and state resulted in statistically significant results. One of which being a study by NREL in 2006, focusing specifically on residential demand, but then also a study done by MIT in 2016 looking at residential, commercial, and industrial demand. Is there, I guess, enough data that we could use to determine a more granular approach for leakage? There was mentions related to, going down to, the basin can have a specific impact compared to one in a different state. But I guess one of the complications could come from the access to data related to that to be able to determine an actual appropriate market leakage value. Reed?
My read of the research is that there is defensible data on the Permian and Appalachia. Permian more so on oil, Appalachia more so on gas. The Permian makes up such a massive share of both gas and oil production that it sort of drives the market. So my gut tells me to run with a generalized leakage factor, except in certain basins where we believe the data quality is high enough to differentiate. And we can work to figure out which basins that is and hopefully expand those basins over time.
Okay. I think that makes sense. Any other comments here? Reason why we shouldn't go with a more defined granular market rate?
Yeah, I think that makes sense if it's doable. I mean, there's a lot of talk about differentiated gas right now too. So, and yeah, I guess in that case too, the more granular, the better.
Yeah, definitely. All right. Well,
Also,
yes, go ahead.
sorry, also not just the leakage rate, but also the average emission intensity of the leakage, as are my updates that, and that also needs to be updated. And I don't know if there's any way we can include distribution capacity. For instance, if a certain basin is at its max distribution, then you're not going to get leakage from that basin.
Puneet, I think if we have basin level data on leakage discounts,
Uh-huh.
that'll take that into account.
Yeah.
And I think Appalachia and the Permian, we're probably going to be able to start with those two.
Yeah. Okay.
Okay, great. We're almost at time. So those of you that, Paneet, Reed, and Meg, that you have, experience related to this, if you can provide any studies, share those with us, that would be great.
Yeah. I'm continuing my kind of just general inquiry on this, and I'll write up any notes that I have.
Yeah, that'd be great. Um, Cool. So we'll just quick touch on next steps. So, as mentioned before, we'll go ahead and post the recording and the slides online. And again, those of you, the work group should provide written comment on the conversations that we've had today and, in previous work group meetings. We will send a doodle poll for availability for potential work group meetings. We'll see where we are after reviewing these comments and just really try to have something on the books just in case if we need one or two work group meetings. Um, and we will also share, revised draft based on our discussions from today and send some sections related to, the assessment boundary and quant and to what extent we can provide a revised full work group draft, we will. And then we'll provide some guiding questions for feedback as well. So at the end of the month, we'll be hosting our annual conference, the North American Carbon World, NACW. So that's why the potential next work group meetings won't be until, beginning or mid of April. So we plan on sharing more information with you all related to the protocol so you can sit and look at the next sections, review it, and provide any written comments on that while we have a longer gap in between the next work group meeting if we have one. And that brings us to the end. Thank you all for today's discussions. It was really, really helpful. We will reach out to you all soon.
Thank you.
All right. Thank you, guys.
Thanks, everyone.